Section 6.2 is long, a little bit long, so we're just going to break it up into two parts. So 6.2a, we're going to talk about properties of graphs of quadratic functions. And the first one, we're just going to go over the ideas of the vertex and the axis of symmetry. And the vertex is the point where the quadratic reaches its maximum minimum value. And the vertical line which cuts the graph in half is called the axis of symmetry. So if we're given the graph, it should be easy to figure out the axis of symmetry and the vertex. So for each of these here, the vertex for the first one is this point right here. And the vertex would be 3, 1. And the axis of symmetry, I'm just going to say axis, takes too much to write in this. The axis of symmetry is going to be x equals the x coordinate of the vertex, which is 3. It'll be the line that basically cuts the parabola in two identical halves. And the next one, we look at the vertex here as a maximum, and the vertex here would be x equals, negative 2. Oh, this guy on my pen is not working here for some reason. Try again. Yep, negative 2, and the y coordinate would be 4. And the axis of symmetry is the vertical line that goes right down through the vertex, so it would have x value equal to negative 2 in this case. And the relationship between the axis of symmetry and the coordinates of the vertex is the axis of symmetry has equation x equal x coordinate of the vertex. Because every axis of symmetry that we're doing in parabolas is a vertical line, and all vertical lines have equation x equals a constant. So if it's going through the vertex, you know that it has to be that same x value. So the next one we have to skip for these notes because I had to do a demonstration in class with graphing technology, so I'm just going to skip over those. You can just basically using graphing technology, graph those two. You can try it on your own if you want, and just look and identify the vertex and the axis of symmetry like we just did. There are some features too that allow you to zoom in and zero in on the max or min point using the graphing features in your calculator. Question 3, how could we determine the vertex from a table of values? And with a table of values, if you look at the y values, so in this case it's starting off at 3, then it goes down to 0, then it goes down to negative 1, and then if you notice the values of y start repeating again, this 0, back to 0 again, and then back to 3 again, which is the same as that one. So you're basically you've started to go down and then you start to come back up again. So this here appears to be where the symmetrical pattern kind of starts. This is a point that doesn't really have a match with it. So these ones kind of match up and these ones match up and so on. So this would be the vertex. Vertex would be negative 2, negative 1. So in this case, you can see that the reason it is the vertex at that point is because it's changing direction. It's going down, and then once it hits that coordinates of negative 2 and negative 1, then it's going back up again. The y values, you can see, start to increase again. All right, so when we look at tables of values, if we can see that pattern, we can identify the vertex. So for example, the first one, you look at the y's are negative 2, then they're going down negative 7, then they're going down negative 10, and going down further, negative 11, but then it starts to come back up again. So there's where the symmetry kind of starts, and there's the middle. So your vertex would be 1, negative 11. In this table of values, you've got an 11, then down to 1, then down to negative 5, negative 7. Then it starts to go back and start to repeat those values again. There's the symmetrical nature, 1 and 1 match up, so this must be the vertex. Now, the next table shows you that sometimes you can't exactly identify the vertex the way we did in questions A and B, because it's going down, 6 down to 2, And sometimes it might actually be going up, and but all these cases, unfortunately, is all going down. But so this is going 6 down to 2, down to 0, then it's back to 0 again. So there is no point there in the middle, where we know it's gone down and it's coming back up again, but we don't actually know the exact coordinates. So when a situation like that, if you just think about it for a minute, if I just kind of sketch the graph here for a second, we know that at -3, there's an x-intercept, because -3 goes with 0, and we know that at -2, there's an x-intercept. This would be 1. So -2. So our graph is kind of doing something like this. If we want to know the axis symmetry, should be right down through the middle. So here we can guess that, could probably figure out the x-coordinate of the vertex would be the average of -3 and -2, because it would be halfway between -3 and -2. So we average that, we'll get -5/2 or -2.5. So we could figure out the x-coordinate, but we really can't figure out the y-coordinate. We could guess that it might be something like -0.5 or something, but we can't really figure out the vertex. So table of values is not always the best way to find the vertex. So if we look at this little investigation here now, it just kind of shows you another reason why the table of values is not the best way to find the vertex. Because if you try to find the vertex in using this equation, y equals 3x squared plus 2x minus 1, and plug in these values. So for the first one, if we quickly do it in our heads, it's square x, put x equals -4 into the equation. So -4 squared would be 16 times the 3 would be +48. And then 2 times the -4 would be -8. So 48 minus 8 would be 40. 40 minus 1 would be 39. Then if we plugged in 3, we square the 3, get 9 times 3 would be 27. 27 plus 2 times -3 would be -6. So 27 minus 6 is going to be 21. And that's 21 minus 1 is going to be 20. If we plug in -2, we're going to get -2 squared is 4, times 3 is 12. 12 plus 2 times -2 is -4. So 12 minus 4 is 8, minus 1 is 7. Plug in -1, we're going to get -1 squared, which is 1, times 3 is 3. 2 times -1 is -2. So 3 minus 2 is 1. 1 minus 1 is 0. Then we plug in 0, we're going to get the constant -1. And then if we plug in 1, we're going to get 3 plus 2 is 5, minus 1 is 4. So when you look at these values, you can see that, again, this is a graph that's opening up. So the y values are starting at 39, you're going down to 20, going down to 7, going down to 0, down to -1, and back up to 4 again. So you know you've changed direction because you're on your way back up again, but the vertex is not obvious from the table, and you can't see that symmetrical pattern. So the vertex is not a real nice value here. It's obviously somewhere between, we know it's somewhere between the point 0, -1, and 1, 4, because that's where the pattern went down, and then it's, it's coming back up again, but it's not easy to see from the table. So what do we do? It's like that. So the next thing we're going to look at is a way to calculate the vertex using a formula. And the first one here, so we're just going to take a bunch of different functions, and I'm giving you the vertex for each of those. That's given to you in the column there, but we're going to investigate a few things now with the a, b, and c values to show you that you can use a formula. So if you know the vertex is 2, 3 for the first equation, that means you know the axis symmetry has to be x equals 2, because it has to have the same value as the x coordinate of the vertex. So in this case, a is what's in front of x squared, which is 1. B is what's in front of x, which is -4. And c is the constant, which is 7. So when we actually calculate the value of -b over 2a, we get negative of -4, because that's the b value, over 2 times the a value is 1. And that's going to give you +4 over 2, which is 2. And if you notice, that's the same as the axis of symmetry and the x-coordinate of the vertex. So if you do, again, for the second one, we see this, we get the same results. So we know that if the vertex is given as -2, -15, then the axis of symmetry has to be x equals -2. The a value in this case is 2, the b value is 8, and the c value is -7. So if we work out the value of negative b over 2a, we get negative 8 over 2 times 2, which is negative 8. Over 4, which is negative 2. So again, the same thing happened. We got the axis of symmetry value and the x-coordinate of the vertex. The next one, if the vertex is negative 4, 2, that means x is negative 4 is your equation for the axis of symmetry. Your a value is negative 2, your b value is negative 16, your c value is negative 34. So therefore, negative b would be negative of negative 16 over 2 times a negative 2, which would be 16 over negative 4, which would be negative 4. And again, we got the same value as our axis of symmetry and x-coordinate of the vertex. And the last one, x equals 1. In this case, your a would be what's in front of x squared, which is negative 3. B would be what's in front of x, which is c. And c would be your 10. So the negative of 6 is your b value over 2 times the a value is negative 6 over negative 6, which is 1. So if we compare the vertex to the axis of symmetry, we know, again, that the x equals the x-coordinate of the vertex is the equation for the axis of symmetry. And if you compare the vertex to the value of negative b over 2a, you know that the x-coordinate of the vertex is equal to negative b over 2a. And necessarily then, the x-coordinate of the vertex, if you know the x-coordinate of the vertex, you know the axis of symmetry because they're the same thing. So how can you determine the x-coordinate of the vertex given any quadratic written in standard form? You can use x equals negative b over 2a. And once you found that, how do you find the y-coordinate? You plug the value of negative b over 2a into your equation to find the corresponding y-coordinate. All right, so once you find x equals negative b over 2a, plug that into your equation for x and work out the y-coordinate that goes with it. So it's basically an algebraic way to find the vertex. So we're going to try this now with some practice questions. So the first one, we want to find the vertex. So we're going to use x equals negative b over 2a. In this case, our a is 3, so what's in front of x squared, and b is what's in front of x, which is 6. So we've got negative 6 over 2 times 3 is negative 6 over 6, which is negative 1. So now the y-coordinate would be 3 times negative 1 squared plus 6 times negative 1 minus 1, which would be negative 1 squared is 1 times 3 is 3 minus 6 minus 1. So that would be equal to a negative 6. 3 minus 6 is negative 3, minus 1 is negative 4. So our vertex should be negative 1, negative 4. The second one, x equals negative b over 2a, is negative of negative 1 over 2 times a negative 2, which is 1 over negative 4. If you want, you can plug that in to your equation as a fraction, or you can change it to a decimal of negative 0.25 if you wish. I'm going to leave it in fraction. So now if I want to find the y coordinate, it's going to be negative 2 times negative a quarter all squared minus negative a quarter plus 4. I'm just simply replacing the x in the equation up here with the negative a quarter. So then in order of operations, you have to do your exponents first. So this would be negative 1 over 4 times negative 1 over 4, which is 1 over 16. This is going to become plus a quarter plus 4, which is going to be negative 2 over 16 plus a quarter plus 4, which is negative 1/8. And then if I put them over a common denominator, this would become times 2 times 2. So that would be 2/8. And this is understood to be over 1. So if I want to put it over 8 times 2, times 8, times 8. So that would be 32 over 8, which would be 33 over 8. So my vertex for this one would be negative a quarter and 33 over 8. So the next question says to determine the vertex, given that the axis symmetry is x equals 0.6. So basically, we know that the axis symmetry value is the same as the x coordinate of the vertex. So we don't actually have to work out negative b over 2a in this case. I mean, if we did, we would get the same answer. But we can just go right ahead and plug it into the equation for x. So x squared would be 0.6 squared now times the negative 5 plus 6 times 0.6, subtract 2. So then 0.6 squared times negative 5 is negative 1.8 plus 6 times 0.6 is 3.6 minus 2. So if you add those up, you're going to get negative 0.2. So that means your vertex would have coordinates 0.6 and negative 0.2. And the last one, if you're given a graph, and this one, the graph is not a real accurate graph in terms of the precise graph, I guess, in terms of the x and y axis. There's very few points labeled. So to find the coordinates of the vertex, you'd be kind of guessing if you tried to estimate where it would be, but you should use the idea of symmetry here. If you know these 2 points are directly across from each other, that means the axis of symmetry should be right down the middle. So the x coordinate for the axis of symmetry should be halfway between 2 points that are symmetrically across from each other. So in this case we got 2 x-intercepts, so it should be the average of the x-intercepts. Which would be negative 2 plus 4 divided by 2, which would be 2 over 2 or 1. So x equals 1 would be your axis of symmetry in this case here. And it would be the x coordinate of the vertex as well. And the vertex looks to be, if this 20 is marking the highest point here, if that's marking the maximum, then the vertex would have coordinates 120. All right, so the last page here is just a summary of everything we've done in this section. And basically you should know by now that the axis of symmetry is the same as the x coordinate of the vertex. As an equation, it would be written as x equals the x coordinate of the vertex. And to find the vertex using a graph, you'd know that you're looking for the minimum point if the graph opens up or the maximum point if the graph opens down, and then just record the x and y coordinate of that point. If you have a table of values, look to see if the table of values shows like a symmetry in the table of values where the values are either increasing and then start to decrease and there's kind of a point in the middle without a match, or if the points are decreasing and then increasing and there's a point in the middle without a match. But if that doesn't happen, then you might have to use an algebraic way. So the algebraic way would be to find x equals negative b over 2a and substitute it back into the equation to get the y coordinate. And there's some questions there now for you to try to practice.